So this is in chapter 8.3, page 672, Gauss-Jordan elimination. Start with systems of equations. So here it is, example 5, which written as a matrix is kind of obvious. That's how it looks like. So, and then the trick is to get this matrix into this kind of form. This is probably not the solution to this one down here, but the form is that you introduce zeros over here. That's called the row echelon form in Gaussian elimination. And then when you complete it, it changes to Gauss-Jordan elimination and reduced row echelon form by introducing zeros here and ones into the diagonal, at which point these numbers here are actually the solutions in x, y, and z. Okay, so let's get started. Example 5. So here's the original matrix. Here's the original system of equations. This here is the original matrix. Okay, now here they notice, oh, we already got a 0 here. Great, right there. So just leave it there and let's see if what we can do. So first thing to do is they swap the first and the second row. So this, oops, not this one, but this one with this one. I highlighted the wrong thing there accidentally. So it's swapping here the first with the second row. That's not necessary. However, in this example, they do want the 1 right there because it's already there. It's right there. So might as well push it up by swapping this first and the second row. All right. Then introducing a 0 right here and a 0 right there. In order to do that, they actually do 2 steps at once. They multiply the first row with -3 and add it to the second row, and they get this. So see the -3 right here, multiplied by the first row, add to the second row. So -3 plus 3 is the 0 right there. -3 plus 1, -2. -3 times -2 is +6, minus 10. There is the -4. -3 times -4 is +12, minus 8 is +4. There it is. Okay. Then they also figure out, hey, let's get rid of that -2 here and introduce a 0 here. Well, multiply the top row by 2, add it to the third. That's what they do here. 2 times the first row plus the third row. So 2 times 1 plus -2 is indeed 0. 2 times 1 plus 0 is 2. Actually, they lost that 0. Well, there was no way around it, I guess. 2 times -2 is -4 plus 9 is 5. 2 times -4 is -8 plus 5 is -3. Right there. All right. Achieved actually a couple of zeros there in the front. Okay, now they're aiming for, actually before they aim for the third 0, right here, they figure, oh, we have just even numbers in the second row, so let's just divide by -2 or multiply by -1/2, which is the same thing, and that gets us a nice 1 right here, reduces everything else to also nice integers, and gets rid of that negative right there. All right, then they're going to figure, okay, now we're going to get a 0 here. The only way to do that is with the second row, because if you use the first row on this one here, you will reintroduce a non-zero number right here, and that's not the goal. So you need to use the second row to keep a 0 right here. So multiply the middle row, the second row here, by -2 and add it to the third. That's what they do here. -2 times the second row plus the third row. The apostrophes that you see here means that over time here, these rows alternated. They changed, is what I meant to say. So this is not the original second row, but this is already like the third time that the second row changed. So anyway, so -2 times 1 plus 2 is indeed the 0 right here. -2 times 2 is -4 plus 5 is indeed 1. -2 times -2 is 4, minus 3 is also 1. And oh, what lucky, there's a 1 right here, and there's already a solution. Z equals 1. All right, now they highlight these 3 here because they need to introduce zeros right here. The way to do that is, one neat thing to notice is that on the when you add the second row to the first row, you introduce a 0 here right away. So that's what they do. They don't do that. Never mind. I would have done that, I guess. What they do instead is they multiply the third row times 2 and add it to the first. So 2 minus 2 is indeed 0 here. 2 minus 4 is negative 2. And then because these zeros here, that's multiplied by the 2, well, that's still 0, so the 1 and the 1 up here stay the same. They do the same thing in the second row, multiply this one by negative 2. So negative 2 plus 2 is indeed 0 here. Negative 2 times 1 is negative 2, minus 2 is negative 4. And then you have zeros here, which you add to the 0 and 1 here, or actually here, the zeros here, add to the 0 and the 1, and that stays 0 and 1. Okay, one more to go, which is this one here. And you can see, just subtract that 1. So 1 minus 1 will be 0, respectively multiply the second row by negative 1. There you go. And so 1 minus 1 is that 0 that you need right there. 1 minus 0, of course, 0. 0 minus 0, 0. And the only difference is that negative 2 minus negative 4 is indeed 2. And there are the three solutions. X equals 2, y equals negative 4, z equals 1. There they are.